And we're back online with Dean Allemang. Dean is going to give us a wonderful presentation on the foundations of truth, how AI can build explanations you can trust. Now, that's an excellent title. It drew me in. Um, Dean is the principal solutions architect at Data.World. He has co-authored a very important book in the world of symbolic AI called Semantic-Web for the Working Ontologist. I don't nearly have enough fingers on my hands to count the domains that he's worked in, but he's worked on a lot. So with that, Dean, your presentation is visible, and I'm going to get out of your way.
Okay, great. Thank you, Joaquin. So I'm going to tell a quick anecdote about Semantic Web for the Working Ontologist. I'm here in Maryland at the International Semantic Web Conference this week. And I was at a restaurant having dinner last night. I wound up, due to bad planning, having dinner on my own, even though I'm at a conference. But just as I left the restaurant, the fellow at the next table stood up and said, "Excuse me, sir, are you Dean Allemang, author of Semantic Web for the Working Ontologies?" Yes, this really happened. And, even though it's been, 15, 16 years since the first edition came out, it's really very gratifying. He said that he'd read it years ago, and it's what got him into Semantic Web. And so it's always nice to know that there are people who came into this field because of that book. So, and it still happens to this day. So I thought I'd recount that little anecdote. So now, foundations of trust. One of the things that we find with modern AI is that we find it very difficult to trust the answers. And I think everybody on the call has probably experienced this in one way or another. You get words like hallucination to refer to this. So I'm going to start my talk with a little clip from a classic cult movie. Now, the setup for this clip, this is a movie called Dark Star. It was made back in the 70s. It was actually John Carpenter's first movie. He was a filmmaking student when he made this movie. Now, the scene I'm about to show you, just a little bit of lead up to it, there is an intelligent bomb, and it's got an artificial intelligence in it that has as its one job in this universe to eventually explode and take out a whole planet with it. The bomb believes it has received an order to detonate, but it's quite premature. And Lieutenant Doolittle has taken upon himself the job of convincing the bomb not to explode. And he's doing this by teaching it skepticism. How do you know that that order you got was real? And so he's talking to the bomb, and that's where we're going to pick up this scene. Let's see how this works.
True, but since this is so, I have no proof that you are really telling me all this.
That's all beside the point. I mean, the concept is valid no matter where it originates. So if you detonate in
9 seconds,
you could be doing so on the basis of false data.
I have no proof it was false data.
You have no proof it was correct data.
I must think on this further.
Okay, so happily for Lieutenant Doolittle, the bomb chose not to detonate. I won't spoil this movie. I recommend that you go see it. You can find it wherever cult movies are found. But the point that I really want to make from this scene, it's running again. That's all I wanted. I want to go to my next slide. There we go. Is this comment that Lieutenant Doolittle makes. The concept is valid no matter where it originates. So if you weren't paying any attention to that movie clip or anything, this is the whole point of why I showed the movie clip. This idea, the concept is valid no matter where it originates. I'm going to use this to talk about explanation of AI. So how does that work? So we'll come back to this idea in a moment. Let's talk a bit about how we have so far interacted with AIs. So typically, and we were sort of trained to do this by ChatGPT. I've lost access to my speaker notes. I'm going to try to find them here. Yeah, I can't find them. So I will just go from memory. When I played the movie, the speaker notes went away. So the way we interact with AIs, and ChatGPT has trained us to do this, is that we have some human being, and I'm talking about a business user here because we're talking about AI in business settings, will ask a question of an LLM. The LLM will do something and get an answer back. And we have a lot of problems with these answers, which have been documented in a lot of places. So how do we go about explaining what the LLM did so we can decide whether we want to trust that or not? Well, if you think about how the LLM does stuff, well, it's got an awful lot of background knowledge. And if we want to look into how did the LLM do what it did, we have to understand the algorithms of the LLM. We have to understand all of those, that background information. We can give it more information when we ask the question. This is using these techniques that are often called RAG, retrieval augmented generation. So we retrieve something and augment the generation by giving it more information. We have all of these things that we need to understand if we want to explain what's going on. And these are some of the approaches that we have seen to explainable AI, where you either train the LLM or give it more information, somehow try to control what the LLM is doing and explain that. Now, let's go back to Lieutenant Doolittle. Is there another way we might approach this? So Lieutenant Doolittle said the concept is valid regardless of its origin. So is there a way that instead of just getting an answer out of the LLM, we could create a concept that could stand on its own regardless of the origin? So we don't actually have to worry how the LLM came to its conclusions. We can look at the conclusions that stand on their own. So to bring this into our business setting here, instead of having the AI generate an answer and try to explain it, we have the AI generate an explanation that stands on its own. Now, how is that possible? It's actually a bit easier than it sounds. So let's talk about that. So what might constitute an explanation that would stand on its own? So I've left the LLM out of this picture. I've still got that same business user on the left that's got their same question. Now, just cast your mind back 2 years ago, before we expected AIs to be doing a bunch of stuff for us. And most people, I think, still operate this way. If you had a business question of your data, you would go to something called a data analyst. You'd ask them that question. They would look at their databases. They'd pick some databases out. They would write a query for you, make a report, and say, there is the answer to your question. And probably in the form of a report. It's unusual questions or yes, no questions or single how many's, but sometimes they are. And they'd write a SQL query against your enterprise database, and that would get you a response of some sort that goes back to your question. Now, how do you trust this setting? Well, on the one hand, you've got your enterprise database that you're curating and governing and so on. You got the SQL query that, yes, was written by a data analyst, but you could actually let any other data analyst evaluate that SQL query and look at it and say, is this actually what we want? And so here are some of the bits of information that you would use to fill out this explanation. So you'd have the database schema of that database. You'd have a data dictionary that describes what the tables, columns, and anything else we use, whatever in that database mean. You'd have the provenance if some of those things themselves are intermediate reports like views and stuff like that. A business glossary to describe how you use certain terms of art in your business. Data quality in the sort of data management world, data quality usually refers specifically to the update schedules of your data. Has it actually been updated recently? Has the data sources it's come from been updated on the schedule we expect? So we're really talking about currency of data when we talk about data quality in this context. And then the SQL query, does it actually answer the question that you asked? Or did you write a query that answered some other question or a very closely related question? And then does the query actually connect to the right things in the database? So if you had all of this stuff, you could look at the thing on the right and say, yes, I have a pretty good deal of trust that I'm getting the answer to the right question. I'm getting this from resources that I trust, and I've put together a query that makes sense. Yes, I can just look at that thing on the right and say, there is a whole explanation that contributes to my trust in what's going on here. Now, let's bring our LLM back into this picture. After all, we're talking about explainable AI, not explainable outputs from our human data analyst. What does the LLM have to do to build this explanation? Well, if it had to build the whole explanation, if it had to describe the database and if it had to come up with the data dictionary and track the provenance, there's no way that an AI is going to do that in response to each question that comes in. But most of the stuff on the right-hand side is stuff that you're already doing, or you should be already doing if you're in an actual data forward enterprise and you've got a chief data officer and you're following best enterprise data management standards and you've got a good data catalog. And here I will plug the company I work for, data.world, who has the only data catalog that's actually backed by a knowledge graph. So this all works out pretty easily in data.world. If you're already, as my colleague Juan Cicada likes to say, if you're already eating your vegetables and doing your exercise every day, you've already got all that stuff on the top. And so that means all the AI has to do is to write that query. And if it writes that query, now you can check that that query is right or not. And that thing on the right stands or falls on its own. It doesn't matter how the LLM did it. The concept is valid regardless of its or how it originates. You don't need to explain what the LLM did. You just have to use its output as something that you can validate and explain. So this is the basic idea that in my position that I'm presenting here in this talk of what do I mean by explainable AI, that we aren't explaining the innards of an LLM. We're not explaining all of its background knowledge. It's creating something that is explainable. So here's an example, and I'm sorry for the elaborateness of this slide. The one that I'm actually going to be showing is my suggested best practice. Is a lot simpler. On the left, you see a relational data schema. Actually, it's only part of it. This is published by the OMG, the Object Management Group, as basically a reference data model for the retail insurance industry. So it's the property and casualty insurance model. And there's a lot of things in here about policies and claims and premiums and so on. And here's a question that our business user might ask. Which agent, and this is an insurance agent, somebody who sells insurance policies, which agent generated the highest total premium amount during the month of October 2024? On the left, you see a pretty elaborate schema. On the right, you see a pretty elaborate query. And the part of this query that I'm going to point out, I've highlighted there in that sort of olive color, is that there is, in one of those tables, there is a field called policy amount. And that field is actually the thing that we use to be able to find out what the premium is. It's called policy amount, but if you look deeply into the schema, you'll find that's actually where the premium is hidden. And then we're doing a lot of aggregations and cross-referencing and so on. And yes, that query on the right-hand side was generated by an LLM, and we can go through it if you're really good at SQL and really patient and say, yep, that actually does correspond to my question, and it makes sense in the schema of this data. And if you had a whole data catalog around here, you could say, yes, policy amount is actually where the premium is, and so on. You could build up your explanation without having any idea how the LLM, or which LLM for that matter, came up with this. And so, as it turns out, to get that explanation, you can actually bring an LLM in at this stage and say, can you finish out that explanation? That was a pretty elaborate query. I don't know if I want to read it all. And indeed, an LLM is pretty good at this. A query is essentially aggregating the total claim amount, the policy amount, corresponding to each agent. The filtering is done based on two criteria. One is that date, and it shows how it did that. And one is by the total policy amount, descending limit one. That's how you get the biggest one. And so you can actually summarize that whole query. And if you believe that summary, and again, you can check this yourself without knowing how the LLM did this, you now have an explanation. Now, that whole story was a little bit elaborate. That schema was pretty hard for us to get our eyeballs around. That query was pretty exhausting, especially for those of us who might not be so good at SQL. But the principle is all there. You could just do this with your enterprise data as you've got it now, with SQL, with enterprise databases. Now, I want to bring in the notion of a knowledge graph here, which is so far I haven't talked about, and talk about how that improves this situation by quite a bit. On the one hand, if you're aware of some of the other work that my colleague Juan Cicada and I have done, we've actually done a benchmark where we compare the diagram that looks, that looks like this, with a diagram that looks like that. and shown that with the knowledge graph, you actually perform 3 times better on a lot of benchmarks, but that's not what I'm talking about today. Here, I want to talk about how explanation is supported by this. So I'm taking the diagram we had a moment ago. We have an enterprise database, a SQL query, and a response. And I'm going to augment this a bit. I'm going to add in an ontology and some mappings. Now, the ontology is actually describing the domain. You can think of it as a logical data model if you come from that kind of data modeling world, only it's really seriously logical. We can prove theorems about ontologies. That's why OWL was invented, to be such a logical language. And then a mapping that maps this back to our enterprise database. Yes, I am always going back to that SQL database because in my career, every time I've walked into an enterprise and said, I want to do some semantic work, some knowledge graph work, every last time, this is no exceptions. All of our data is in a great big relational database and it's not moving. If you can't do your knowledge graph on top of our relational database, let's end this meeting now. And so we don't want to end the meeting now. So we said, well, actually, yes, we can. We will describe your data using an ontology, use a standard mapping language to say how the ontology maps to your enterprise data. Then we can do Sparkle queries over that knowledge graph. And we have a taller stack here with more pieces in it. But just like before, that thing on the right can be explained independently of how it was created. And what do we need now? We actually need a little bit less. We still want provenance, business glossary, data quality. Those things are kind of outside of the data itself. But a lot of that stuff about the data dictionary, the schema, all of this sort of stuff is now inside the ontology. We still need to know if the query is connecting the right stuff in the ontology and does the query answer the question. And once again, we can have an LLM do this. Now, it's worth pointing out, well, wait a minute, what does the LLM need to know to do this? Well, it actually needs to know the ontology and all of these things out here, the provenance, data quality, business glossary, and so on. But it turns out that all the LLMs that are sort of out there, the open source ones and the commercial ones, already speak OWL and Sparkle quite well. They've seen millions and millions of these things out in the world. So they do a good job of this. And I'll go through my example here. I see I'm running short on time here. So the same question, which agent generated the highest total premium? On the left, we see the fragment of the ontology that describes this same insurance domain. A lot of the details of that schema that you saw in the first one are actually put into that mapping where we say things like, for instance, the premium comes from this field called policy amount on a certain table, and the way you get from the policy to the agent is through a certain join and so on. All of those things are in the mappings. And so what you see here is sort of a business level thing. A policy is sold by an agent. Now, in this model, policies are broken into things called policy coverage details, and that's where you have the premiums. So I actually want to show what happens when the LLM hallucinates. So here it wrote this query, and I'm going to highlight some things in here. It said the policy is sold by an agent. Okay, so that's going along this link. And the policy also has a premium. Whoops, wait a minute. Policies don't have premiums. Policy coverage details have premiums. The LLM used its background knowledge where it thought policies had premiums, and it made a mistake. We've all seen LLMs make mistakes like this. It happens literally every day. But because ontologies are logical structures, and Sparkle is actually a graph language, the Sparkle itself looks like a graph, it's a really easy job to say, those two lines don't fit the ontology, please repair. And once again, the LLM is really good at this, especially if you focus it exactly on what it needs to do. So there is a thing called a coverage detail that has the premium, and a coverage detail has the policy. And now the rest of the query is pretty much the same. Find the agent that sold it, found the dates we're talking about, group by the agent, add up the premiums, and take the biggest one. So on the one, so what has the knowledge graph done for us here? Well, first of all, it's made it really clear to see how do we compare the query to the knowledge graph? How do we repair that? And it's even pretty easy to look at this much shorter query, understand overall what it's doing. But if you don't want to do that, we can still ask the LLM, and you get a very similar answer here. The query identifies the insurance agent, and it even tells you about this notion of a coverage detail that's going to help you mediate between these two things. So what's the role that the knowledge graph played in here. First of all, how did you know premium amount was the right property? The ontology told you. How did you know that that actually goes off to a column in some table called policy amount? The mapping told you that. How do you know it's the right database? Your data catalog has an index of what database is actually good for what. How do you know the data is up to date? That's your data quality, again, inside of your data catalog. How do you know the query is correctly formulated? Well, we saw a failure in that. You could take the ontology and the query and check that. How do you know the query answers the question? Well, the LLM can explain it, or sometimes you can just look at the Sparkle and figure that out. So this is my image of ontology to the rescue. Ontology is an ancient Greek superhero swooping in. The AI can generate an explainable solution, and the ontology makes this more effective and easier to explain. So the verifiable explanation leads to trust in the response. I'm afraid I went over a little bit, Joaquin, but hopefully not too much. I can't hear you, Joaquin.
We're good on time. We have a little break after this, so we have a little bit of a chit chat that we can.
Oh, okay, great.
Pardon. It's really cool to see you break this down in a very mechanical level from what exists today and what is an ideal circumstance that you've proven in your current employment scenario. What really what this stimulates in my mind is this is no different than getting a new employee at your restaurant or your whatever company you hold. You have to train them. You have to give them guidance. You have to give them an employment manual, employment contracts. They need to know what is okay and what is not okay within the boundaries of the arrangement that you have. But whether it's an agent, whether it's a person, it still serves the same. You have to be able to trust that they can explain the reasoning on how they do things based on the rules that you provide.
That's right. This, in some case, in some sense, everything I'm describing would actually apply to, in the case we're talking about data here, a new data analyst. The data analyst comes in and gives you not even a new one. In fact, one that's already there. They give you an answer. And you say, gee, is this really the answer I want? You're going to ask the same questions. Is it the answer that I want? Was it actually done the right way? Did you use the right data source? These are all the things you would ask of a human. And you actually don't need to know how the human did it. You can imagine a very experienced data analyst who just goes, I don't know how I write queries. I've done this so long. I just know how this thing works. You've known the data analysts like that. I knew someone at one of the banks I worked at. She was very useful to help us in building our knowledge graph. And then you have someone fresh out of college that's going to come in and say, well, this part of the database is in this normal form, but they kind of designed it badly. This part's in a different normal form. So when you write your query, and they can give you all sorts of explanation of what they believe they're doing. And honestly, you don't care, right? At the end, you'll look at the query and say, am I getting the right answer there? And how they came to it, whether the old timer just has gotten used to it and just, that's the way we do things around here, or the newcomer goes in and brings in all the theory they learned in school. Both of these are valid approaches, but when the rubber meets the road, is it the right query and does it run against the right database to get you the answer you can trust? And if you think, hey, maybe that wasn't quite right, you could go back to the original data analyst who did it, but they may have moved on. You might not have access to them, but the query you do, the database you do, and the ontology. I don't want to underemphasize the role of the ontology here. This whole story works fine in a pure SQL world, but if you really want to have explanations that are a lot simpler, and you saw my diagrams there, that schema was quite a mouthful, whereas the ontology, a lot of the complexity of the schema gets swallowed up in those mappings. And you can crack those open if you need the details, but you almost never do. And so the ontology is in some sense a very convenient abstraction that allows you to make your explanations at a higher level. And as it turns out, in generating your queries, and that's not the point of today's talk, but that's what Juan and I will be actually talking about tomorrow here at the Semantic Web Conference that we're at, is that your LLM can actually be a lot more effective at creating queries, based as the ontology is simpler, can pay more attention to the important things, and so it gets the right query more often than not. And then, my favorite, of course, I'm going to, if I can get my way back to that presentation. I don't know how to move that around. There we go. If I go to here, no, not there, to there. Here we go. This little bit here. How did we find out that this was wrong? You know, because I'm a semantic web guy, I looked at this and said, this is a straightforward, if this would be a student project, except I don't have students, how do you compare a Sparkle query to an ontology and say, yes, it's right, no, it's wrong. If it's wrong, write out the way it's wrong in little pseudo-English sentences, because the LLMs like pseudo-English. Finish that in an hour. And I saw a presentation yesterday here at the Semantic Web Conference from the Swiss SID, what is it? The Swiss Information, it's the Biomedical Information Group in Switzerland. They had actually done exactly the same thing. You know, this is for a semantic web person, this is an obvious thing. Compare a Sparkle query to an ontology and talk about what went wrong. And this has made it so that you know, the trust in this thing, you don't even know that we're doing it. But when we're all done, we have a query here that matches the ontology, and I guarantee that it matches the ontology. If it didn't, you know, the whole thing would fail. And so Juan and I have written that all up in the paper that's actually appearing in this conference this week, the ISWC paper. We've written up all the details of that, so that we're not considering that protected IP because, well, it's obvious.
Dean, thank you very much for your presentation. Just want to say Liz McLean is saying welcome to Maryland.
Hi, Liz.
So yeah, we're going to take a brief intermission.
Okay.
We should be back in about 24 minutes.
Okay.
So yeah.
All right. I'll see you then.
See you guys soon.